Hello everyone, welcome back to the computer fundamental classes. In this class we are going to discuss the important concept in second unit, that is called as UNICODE. Okay, what is that? UNICODE. In this class we are going to discuss this one, that is called as UNICODE. So before discussing UNICODE, in previous class we discussed about the computer codes. Yes, in previous class we discussed about computer codes. In that we discussed 4-bit binary coded decimal and 6-bit binary coded decimal and also extended binary coded decimal interchange code and ASCII code. These all things we discussed in previous class. Okay, so after that now we are going to deal with the UNICODE. Okay, UNICODE. So what is the need of UNICODE? Right? Need for UNICODE. What is the need for UNICODE? Right? So in this class we are going to discuss what is the use of UNICODE or what is the need of UNICODE. Okay? So you know already, nowadays a computer become a popular tool. Right? The computer become a popular tool. You know already, because worldwide we are using computer to reduce human effort. Okay, so for that reason we are using computer. That is what a computer become popular tool for doing all kind of data processing across the world. What is that? The computer that can do all kind of processing or all kind of data processing across the world. So here I am explaining what is the all kind. Here all kind of data processing. What it means? All kind of data processing. That means the computer can do any task, okay, that process the any type of data inside the computer. That is called as all kind of data processing across the world. Okay, so their usage could not be limited to English language. Okay, so up to here what we are thinking, the computer only work with English language. The computer only work with English language. That is not a matter. Okay, so the computer usage could not be limited to English language users only. Who know the English? Those people can only work with computer. Okay, so that is not a matter. That is not a matter. Okay, so hence people starting developing computer system that could allow interaction and processing of data in local language of users like Hindi, English, Kannada, Japanese, Korean, Chinese. So these type of language would be supported. Okay, for that reason the developers or researchers developing computer system, that is called as UNICODE. Okay, computer system. So now, so here that can support the local language, local language like you know already, Kannada is a local language. Okay, and Hindi is also local language. Okay, and Chinese is also local language. Not Chinese is a local language in India, that is in China, that is a local language. And Japanese, okay, Japanese and Telugu. So these are the local language supported by the UNICODE format. Okay, so for that reason they are going to develop UNICODE. Okay, now this required, okay, so this type of local language required support of local language characters and other language specific symbol on these computer systems. Okay, So if you want to type in Kannada, if you want to type in Hindi, Chinese, Japanese, Telugu, we need the related characters. If you want to type Kannada, we need Kannada related characters. If you want to type Chinese, we need the Chinese related characters. Okay. So for that reason, we need the Unicode. Okay. So here now we are going to discuss Unicode. So why we need Unicode? Okay, no single encoding system supports all languages. Okay, no encoding and single encoding. That means for example, in previous class we discussed what is that, ASCII or extended binary decimal. Okay, extended binary coded decimal interchange code. That cannot be support for all language. ASCII is not support for all language. Okay, so if you want to type in any local language, we need another character coding. Okay, so for that reason we need Unicode. Different encoding system conflict. Different encoding system conflict. For that reason we need Unicoding. Okay, so what are the Unicoding features? If you are using Unicoding, what are the features? Okay, so what it does, it provides a consistent way of encoding multi-language and plain text. Multi-language and plain text. That means if you are using Unicode, that gives a consistent way of encoding for all languages, all local languages. When you are going to type in computer, that supports your all languages, all local languages. Okay, and it defines code for characters used in all major languages of the world. Okay, and also defines code for special characters, mathematical symbols, technical symbols. Okay, so for that mathematical symbols also, technical symbols also, or special characters also, we can use any code. Okay, so that related characters they are using. Okay, and after that, what are the encoding forms? This is very, very important. What are the encoding forms? So here there is one word that is very, very important. Capacity to encode as many as million characters. Okay, so if you are using Unicode format, there is a capacity to encode. For example, if you translate any language, okay, for that has a million characters to translate one language to another language. Okay, that is called encoding. Encode means translating one language to another language, you can translate. Okay, so there is a huge capacity to encode as many as million characters. You can translate any character. Okay, assign each character's unique numeric value and name. Okay, so after that there are so many forms or many very, very important forms in encoding, that is called as UTF-8 and UTF-16 and UTF-32. Okay, what it means UTF and UTF-16, UTF-13 we will discuss now. Okay, so UTF-8, in addition to defining the identity of each characters and its numeric value, is known as code point. Okay, the character encoding standards also define internal representation, is also known as encoding form. Okay, that means, see here what I explained encoding here. Encode means the character encoding, that is called as character encoding standards also define internal representation. For example, if I enter something in Kannada, okay, that can encode that Kannada language into internal representation for binary or any other coding. This is called as encoding. Okay, of each characters. Okay, Unicode standard defines there are 3 encoding form for each character. Okay, that is called as UTF-8, second one is UTF-16, then UTF-32. Okay, so what do you mean by UTF-8? UTF-8, that means Unicode transformation format, that is called as UTF-8 is Unicode transformation format 8. That is the full form of UTF-8, Unicode transformation of format 8. Okay, format 8. So what does it mean? So why you are using UTF-8? Okay, what is the use of UTF-8? This is a byte-oriented format having all Unicode characters represented as a variable length encoding of 1, 2, 3 or 4 bytes. Okay, so like this they are coding. For example, when you purchase 8-bit computer, suppose assume 8-bit computer, what it does, okay, the 8-bit computer only can store 8-bit format. Suppose I enter something like this. Okay, this is a one word. Assume this is a one word I entered here. But the UTF format only translate the at a time 8-bit, not up to here, not full length of this word, full length of this word. Only that can translate up to 8-bit. Okay, so that is called as the UTF-8. Okay, the UTF-8. So the UTF-8 is a computer hardware device or software program capable of transferring 8-bit of data at a time. What is the UTF-8? That is capable of transferring 8-bit of data at a time. Okay. For example, early computers processor like 8088, 80286 were having 8-bit or 16-bit. Okay, meaning they were capable of working with only 16-bit binary numbers. Okay, here also format 8, that is called as UTF-8, only work with 8-bit format, 8-bit binary numbers. Okay, that is called as UTF-8. Okay, now after that UTF-16, UTF-16, right? UTF-16. That means Unicode transformation format 16. Unicode transformation format 16. Here, this is capable of transferring the data 16-bit binary at a time. Okay. Suppose if your word having more than 16-bit, suppose if your word having more than 16-bit, that can divide it into 16-bit. Okay, then only it can transfer the data at a time like this. Okay, so here this word contains 32-bit. Suppose in UTF-16 this word contains 32-bit. What it does, that can divide full word into by 16 into 2 words, 16 into 2. Okay, so now it can convert, it can translate 16-bit binary number at a time. That is called as 16. This is a word oriented. The 16-bit is the word oriented. Okay, word oriented format having all Unicode characters represented as a variable length encoding of 1 or 2 words. Okay, so you know already one word equal to 16 bits. Okay, so one word is equal to 16 bits. Okay, one word is equal to 16 bits, or one character is equal to 8 bits. You know already. Okay, one word is equal to 16 bits. This form is useful for environments that need to balance efficient access to characters with economical use of storage. Okay, then next one is UTF 32. UTF 32. What it means? This is here. The first one is what? This is called as byte oriented. This is called as byte oriented. This is called as word oriented. Okay, so this is called as double word oriented. Double word oriented. Okay, double word oriented format having all Unicode characters represented as a fixed length encoding of 2 words. Okay, so one word equal to 16. Now 16 plus 16, that is called as 32 word, 32 bits. Okay, so this is double word, 32 bit code unit encodes each character. Okay, so what it means, nowadays we are using 64 bit characters. Okay, so 32 bit characters means when you enter like this, that can take only up to 32 bit. Okay, after that it again takes 32. Okay, the maximum size is 32 bit. Okay, so now new computers allows the 64 bit computers. So nowadays the 64 bit computers, that means that can store the 64 bit in one word at a time. 64 bit in one word at a time. You can translate the data, or you can transfer the data up to 64 bit at a time. Okay, that is called as UTF 64. Okay, so these are the called as the main three Unicode data transformation, that is called as UTF 8, UTF 16, UTF 32. Okay, the next one is what? Next one, collating sequence. The next one is a collating sequence. What is the collating sequence? Collating sequence defines the assigned ordering among the characters used by computers. Okay, so you know already the keyboard have a various characters. Okay, so various characters placed on keyboard. For example, it may be numeric characters, it may be alphabetic, it may be lowercase, special characters. Okay, so those characters having one value. Okay, it may be octal, it may be hexadecimal, it may be binary, anything. Okay, the every character have its weight. Okay, so the data processing operations often use alphanumeric and alphabetic data elements. Okay, obviously we do not intend to perform any arithmetic operation on such data. Okay, so for example, you can perform any arithmetic operation on alphabet or special character. How we are performing? Okay, if you want to perform, I want to find out the greater than between A and B. I need to find out which is the greater, which is the small. But how you are performing? For example, here you can assume A is less than B. This is an arithmetic operation, or this is logical operation, right? So here we need to find out which is the small, which is the big. Okay, so for that, in collating sequence defines assigning order. The every data, every characters are in order wise. Okay, so for that we can easily identify which is small, which is big. So you can identify ASCII characters. Okay, there we have a number or order wise. Okay, the collating sequence may vary depending on the type of computer code used by a particular computer. Sometimes the collating sequence order may be indifferent depending on the type of computer code. Okay, some people are using different computer codes. Some computers having different computer codes. So there may be vary. Okay, so in most computer collating sequence follow the following rules. Okay, what is the following rule? So according to, for example, here I will write here A, you know already. A is a character, B is a character, C, D, E, F, G, H, I, J, K, L, M, N, O, up to Z. Up to Z. What it means? In collating sequence, all are in order wise. That means A is smaller than B, B is smaller than B, and B is greater than A. Okay, C is smaller than D and C is greater than B, and Z is smaller than Y. Okay, sorry, Z is greater than Y. So also Z is greater than all remaining characters. So like this they are ordering, that is collating sequence. Okay, then only you can find out any arithmetic operations on these characters. For example, I need to find out A and B. Okay, A and B. In which two characters, which is a big, which is small, we don't know. But when you performing like this, A is greater than A is greater. A is greater than B. Okay, so if the condition is true, for example, A is less than B. Okay, it is obviously true because here A is smaller than B, because according to collating sequence we are order the all characters in alphabet. Okay, so also in like in small letters also you can use. Okay, so here the letters are considered in alphabetic order like this: A is less than B, B is less than C, and B is greater than A up to Z. Digits also we can use like this. Okay, numeric also order, that is digits are considered in numeric order. 0 is less than 1, you know already. 1 is greater than 0, 1 is less than 2, 2 is greater than 1. Like this we can use collating sequence. Okay, so these are the sorting in extended binary coded decimal interchange code. Okay, so this is example. You can see A1 is less than 1A. Okay, 1A is greater than A1 and A1A is less than 23. So this is a sorted order. Okay, so this is called as UNICODE format and collating sequence. Okay, in collating sequence may vary from one computer system to another depending on the type of computer and coding schemes used by a computer. Okay, so these are the collating sequence. I hope this is clear to you. In next class we are going to discuss the arithmetic operations. Okay, in next class we are going to discuss computer arithmetic on binary. How you are adding the binary numbers, how you are multiplying the binary numbers, how you are dividing the binary numbers. Okay, how you are subtract the binary numbers. These all things we are going to discuss in next class. Okay, thank you.